Right, these are going to be some questions similar to those you'll find in the DBA and the test for Module 1. So first, evaluate each expression. So remember, what you're doing here is you're going to be using PEMDAS. So you have to really keep track of where the parentheses are. That's a big part of this. And I'm actually going to highlight some parentheses here so that we can keep track of them. Those are those outer parentheses. And then we've got some right there. All right, so, oops. And already I'm making a mistake. So that needs to go here. And also then we have these ones here like that. All right. So parentheses, we start on the innermost thing. So inside of these parentheses, we have these parentheses, but there's nothing to do. So we just have to combine those terms, negative 26 and negative 10. So we have 2 minus, negative 26 minus 10 is negative 36, divided by, and now we're looking here, and inside there, we just have an addition, it's of a negative number, and a subtraction. So we do those from left to right. So 10 plus a negative 4 is 6, and then we still have minus 2. All right, so inside those parentheses on the far right there, we still have more to do, and that's going to be 4. So now all of our parentheses are simplified as much as possible. Now we have parentheses, exponents, there are no exponents, multiplication and division from left to right. So although we have this subtraction here, we have this division, which is first. So that's going to be 2 minus, and negative 36 divided by 4 is negative 9. And then 2 minus negative 9 is 2 plus 9, which is 11. All right, here, so we have the parentheses here and some parentheses here. And then we also have these parentheses here. Nothing to do inside those, though. So inside of these parentheses, we can do PEMDAS inside there. There's just a multiplication. Negative 2 times, or negative 9 times 2 is negative 18 divided by. And then inside these parentheses, well, there's nothing to do inside there. Then exponents. So it's negative 2 squared. So we have 10 minus a negative 2 squared is a positive 4 minus 8. So we still have more to do inside those parentheses. And it's just a couple of subtractions. So we go from left to right. 10 minus 4 is 6 minus 8. And I can get rid of those parentheses there. 6 minus 8 is negative 2. Negative 18 divided by negative 2 is positive 9. And that is that one. All right. Solve each equation. So here, what I'm noticing is that I have this positive 2n on the left and the negative 3n on the right. I'm going to subtract, or no, let's add 3n to make that a 0 on the right. You can do either way. I could have subtracted a 2n as well. Doesn't really matter if we do the rest of our steps correctly. Now we need to get this n term by itself, so we want to undo the addition of a positive 4, so we subtract 4 to make a 0 there, and we get 5n equals 0. And now we have to divide both sides by 5 because we have 5 times n. The inverse of multiplication is division. Dividing by 5, 0 divided by 5 is 0. I hope that you could see that question from the beginning. If not, I'm really sorry about that. All right, here we need to distribute are 5. 5 times n is 5n. 5 times 2 is 10, so we have 5n minus 10 plus 1 equals negative 9 plus 2n. I'm going to combine these terms right here. So I have 5n minus 9 equals negative 9 plus 2n. Now I'm going to subtract 2n. Did I do something silly? I think I might have. We have 3n minus 9 equals negative 9. And adding 9 to both sides. I ended up with another situation. Divide by 3, and we get n equals 0. Two variables equal 0 in a row, that's kind of weird, but I guess it can happen. All right, now when we're dividing by 21 on this left-hand side, we have this entire thing right here that's being divided by 21. So if we multiply both sides by 21, what we do is those cancel out, and we're just left with the b minus 10 on the left and negative 21 on the right. Adding 10 to both sides, we get b is equal to negative 11. All right, so that's it for the solving for now. Here we need to write equations to model the situation. So we have a computer technician charges $75 for a consultation plus $35 per hour. She made $127.50 from her first job of the day. Write an equation to show how many hours she worked on this job. All right, so one thing I want you to see is this per tells me that we have a multiplication. Here, this says addition. And that's mostly the real big hints in this one. $75 for a consultation, 75 plus $35 per hour. So that's the 35 per means multiplied by the number of hours. So this is a multiplication here. And H stands for the number of hours, equals $127.50. And that is the way to write that equation. You could then solve for H. And if you do, it's going to end up being 1.5, I think. George and Marco each play chess. Marco has won 6 fewer games than George. Is it possible for George to have won 9 games if the sum of the games Marco and George have won together is 30? Okay, so one thing I notice here is that fewer means there's a subtraction involved. And we have Marco and George. So let's see. So let's say that George is 9. So George has won 9 games. So I'm going to highlight that. George has won 9 games. So George has 9. Marco has won 6 fewer games than George. So we're the sum of the games. Oh, let me go down here. The sum of the games of Marco and George have won together. And then I'm going to highlight one more thing here. This is almost always an equal sign. So we're adding here. So we're going to add 9. That's how many George has won. And Marco has won 6 fewer games than George. So we could do 9, that's the number of George, minus the 6. So this is that Marco has won 6 fewer games than George. and we're adding that to the number that George has won because the sum of the games they've won together is 30. And is this possible? No, because that's 12, and that does not equal 30. So this is not possible. Oops, not possible. They have won 12 together. There we go. All right. All right, solve each inequality. So when we have an inequality, I see that we're going to need to combine some like terms. We treat it mostly like an equation. There's one kind of situation where it's different. So we have negative 1b. I could just say negative b. That's fine. Minus 5 is less than or equal to negative 2. So I just combined those terms right there. And now I'm going to add 5 to isolate my b term. So I have negative b, or negative 1b, is less than or equal to 3. And now, because I'm multiplying my b by negative 1, I have to divide by negative 1. Whoops, not negative b, just negative 1. And when I divide or multiply an inequality, both sides, by a negative number, like I am here, you have to switch the sign. So it becomes b is greater than or equal to negative 3. So notice that my sign switched directions. It did keep the possibility of equality as well. Write an inequality for the situation. Alfred's weekly income is at least $500 with a fixed income of $200 for working at the bank and making $12 per hour at another job. Write an inequality that can model this situation. So again, here we have this per hour. We have a fixed. That means there's going to be an addition of this 200. We also have at least 500. So whatever it is we're talking about, it is going to be greater than or equal to, so at least 500. We have the 200, that's the fixed income, plus for working in the bank, and $12 per hour at another job. So here we have $12 per or times the number of hours. So that is our inequality for this situation. Whoops. Solve each compound inequality. I find it's helpful here to break this compound inequality into two inequalities. So you can see I just took this right there and then this over there. And so I'm going to solve for each of them. I can add 5 here and get negative 5 is less than or equal to x. And we also here have to add 5 there, and we get x is less than negative 3. So now we can combine these two back into a single statement, and we can have negative 5 is less than or equal to x is less than negative 3. A company that makes golf balls needs to ship bags of balls that contain 690 balls plus or minus 6 balls. Write an inequality that expresses the acceptable number of balls in each bag. And that should say each, but it doesn't. Oh well. All right, so the number of balls in each bag, let's call that x. Now when we subtract 690 from it, so it can be greater, the difference between them can't be more than 6. So that's a situation where we need absolute values. So if x is bigger than 690, this will be positive. Let's say it's 695 minus 690. That'll be 5. Absolute value will equal 5. If it's 685, then it'll be negative 5 absolute value, which is positive 5. So either way, we'll end up with a positive number. And the difference between those has to be less than or equal to, that is not a very good symbol, less than or equal to 6. And that is how we would write that one. Here's the last problem. It's a long video, so good job sticking with it. We need to solve this equation for a. So what we can do is we can add 3 to both sides, and we get z plus 3 is equal to 2a. And now, since we're multiplying a by 2, the inverse operation of that is dividing. So we divide both sides by 2. So we just have z plus 3 divided by 2 is equal to a. And that is it, my friends. I hope that this has been a useful video for you. Let me know if you have any questions.